Hi guys, in this video we will discuss about a 5 number summary. It's a part of descriptive statistics. It is used during preliminary investigation of a large data set. Let us get going with a small data set and understand what exactly it means. So we'll say minimum value is 1, maximum value is say 20, and size we will consider as 20. And then we will create one variable called x using this command randint minimum value maximum value plus 1 and then 20 n. Done. So this is how our data set looks. Let us create a data frame x. We will call this column as x, and then we will say, let us run this. Okay, data frame is ready. We can see top 5 records, and then here we are going to use very useful method, that is describe. What does it do? It tells us the count of the data set. How many numbers are there? 20. Average of this data set, that is 9.35. Standard deviation of this variable called x. Minimum value is what? 1. Here maximum is where it is 19, 25th percentile, 50th percentile, and 75th percentile of data is something like this. This can be depicted by using a box plot, but box plot will talk about only 5 properties. Plot will not give us the count, the average, and standard deviation. So let us create a box plot, box, and then we'll say x, we'll say vert is equal to false. Maybe we can also define size of the graph like this, 15.5, and then say show. So there is some problem here. What it says, word false. Okay, box plot. Okay, that was syntax issue. Okay, great. Now, what does it show us? See, this is what is called box plot. This is minimum value. What is that? Let us check. We know what is minimum value, right? That is 1. We can also write here minimum x 1. Let us check maximum. We already know that is 19, right? It is already shown by data frames describe method. Maximum 19. Good. Then percentile x 25th percentile 5.25. Then this can also be seen by writing quantile, but we should write within the range of 0 and 1. So we'll say 0.25, not 25, but 0.25. It will give us the same value. Great. Next, median, that is 8. We can also see like this, percentile x 50 or quantile x 0.5. All these 3 commands are giving us 8, 8, 8. Now let us check for 75th percentile. What we will do, we will write in next line, that is getting crowded, 75 and here 0.75, sorry, 0.75, 13.75 here. Okay, then maximum we have already seen. So we are by default getting 5 properties, and hence the name 5 number summary: minimum, maximum, quartile 1, median or quartile 2, quartile 3. We can also talk in terms of percentile: 25th percentile, 50th percentile, and 75th percentile. What does this mean? This means that till this point, 25% of the data lies, and till this point, 50% of the data lie, and here 75% of the data, and till here all 100%. Now let us talk about something more which is not visible over here. That is outlier. Now, outliers could be at the lower end as well as at the upper end of the data. So we call them lower outliers or upper outliers, and they are calculated. How they are calculated? Before we calculate outliers, we should know what is interquartile range. That is nothing but the difference between quartile 3 and quartile 1. How we will get quartile 1? We already calculated. We can say that NP percentile x25 or NP quantile x comma 0.25. This gives us quartile 1. We will calculate quartile 3 by saying $75. We got this? Now what we will say? Interquartile range is equal to Q3 minus Q1. We got it. That is what is called interquartile range. So let us look at that. IQR. 8.5 is the range from here to here. Okay. So what is our 75th percentile? 13.75 minus what is our first quartile? The value is 5.25. What we are getting? 8.5. So we got it. Now we are ready to calculate outliers. How will do that? We will say IQR multiplied by 1.5. Then we will say Q3 plus the data above this value will be declared as outliers, upper outliers. Now here, come down and make it Q1 and say minus. The data below this will be declared as lower outliers. 26.5 minus 7.5. So we will not touch this graph, but we will try to have some outliers in our data set. We will not disturb this. So we already have X here. What we will do is we will insert two values and see whether they become outliers or not. But before we do that, we must remember that when we are inserting records into our data set, any data points into our data set, everything will change. Our Minimum might change, maximum might change. Suppose we are inserting a value which is less than minimum, so minimum is going to change. If the value that we are inserting is going to be more than max, the max will change. Accordingly, quartile 1, quartile 3, and median could also change, right? So it will have impact. Now, hence, we cannot, by this particular formula, we cannot simply say that now we will write 7.6, that will become outlier, and we will write 26.6, that will become our upper outlier. That may not happen because the values which we are going to insert, they are going to impact. Again, recalculation will take place for lower and upper outliers. Hence, we will insert much lower value and much higher value, so that anyway, even after recalculation, they will be considered as outliers. So what we will do? We will say x is equal to np append two values we are inserting. Okay, just see how we are going to do about x. Then here minus 7.5, right? We will write maybe 12, minus 12 we will write. Okay, and here we will see 26.5 is going to be upper according to existing data, but these two data will go and change the value for outliers. Hence, maybe we will write say 40. Now the x value is like this. Okay, let us create data frame, right? And then we will say describe. What are we doing? For fresh x data frame, which means what? Minimum value change and maximum value change, and I think 25th percentile, 50th percentile, 75, every change. I'm not sure about median. Median, I think, remained same, but 25th percentile, what was it? 5.25. Is it same or it has changed? Yeah, it has changed to 3.75. And 75th percentile, it was 13.75. Now what it is? It is 15.25. Now let us see whether the values which we inserted minus 12 and 40 are going to be considered as lower and upper outliers respectively or not. Okay, so we will draw box plot afresh. Here we go. See, 40 is considered as upper outlier. However, this minus 12 has not been considered as lower outlier. We can calculate and find out what. In the given data set, what is our Q1? That is 3.75. Okay, 3.75. What we do? We say minus. What is our interquartile range? That we have to calculate again. So what we will do? What we can do is we already calculated. Yeah, we calculated here. Let us bring this and okay, let us remove this. We will calculate and see our interquartile range is now for the new data set, it is 11.5. So what is our Q1? Q1 is this. So what we will say? Q1 minus interquartile range multiplied by 1.5. What value we are going to get? Minus 13.5. And what we inserted? We inserted minus 12. Hence, lower outlier is still not there. As was discussed, that when we are inserting data, everything is going to get changed. The entire calculation will have to be done all over again. Now let us do one thing. We will again insert some value which will be much lower and another higher value which will be much higher to make sure that we are getting both the outliers this time. So what we will do, again we'll say x is equal to np append x. Okay, so what we'll do, let us be very ruthless this time. We'll say minus 50 and with this place we'll say 70. Okay, now what happens? Our x is this. Okay, and just let us run this. What we will run? This 3 lines to draw box plot. Here we go. We have lower outlier 1 and 2 upper outliers. Okay. Before we wrap up, let us read out this brief note on 5-number summary. It is a part of descriptive statistics. It is used when we initially try to get an insight into the data set in question. We know it shows 5 values: minimum, maximum, then quartile 1, quartile 2, quartile 3. Okay. And the data is automatically sorted in ascending order. If that doesn't happen, how it can draw this graph? It has to be in ascending order. Look, 2.25, 17.5, this was minimum was 1 and maximum was 20, right? It was in ascending order. Good. The data may not be in ascending order. When we are drawing box plot, automatically it will sort and show us the graph. Instant insight into the central tendency. How much data is located? Look, this is 50% of the data lies here between Q1 and Q3. 50% of the data and 25% of the data is from here to minimum to quartile 1 and between quartile 3 to maximum 25. So this is 25, this is 25 and this is 50. So this is middle 50, this is lower 25 and this is upper 25%. Correct? Good. And then represented in a diagram known as a box plot. This is what is called box plot. And we also saw outliers like this. We will get deeper into 5-number summary. We will draw a graph which will show us standard deviation and mean also. Though these are very, very important properties pertaining to any data set, and 5-number summary remains silent on those properties. So we can customize this graph to show standard deviation as well as mean. Okay, there will be another thing that we would be interested to see. We would like to see what are the values which come below quartile 1. What are the values which are more than maximum? That means outliers. We want to see all the outliers data, not in the graph, the data. We would like to see all the data which are between quartile 1 and quartile 3. All these things we will explore in the next video. Thanks for watching, and I will see you in the upcoming video.